are two major goals of this section. First, you need to learn how to graph a simple exponential function by hand. So we did that. The other major goal is to learn how to solve an exponential equation. Okay, so that's what we're going to turn our attention to now. Okay, before we delve into how to solve certain exponential equations, we need to have a review of the laws of exponents. Okay, so about the middle of page 3, you will see this little box with the laws of exponents. There are 6 laws of exponents that will come in handy when solving exponential equations. So let's talk about those. Okay, so it says if S, T, A, and B are real numbers with A being bigger than 0 and B being bigger than 0, then the following rules apply. Okay, so just S, T, A, and B are numbers. Okay, so here we go. The first rule here says 1 to a power is what? Okay, well, we know, if you start doing powers of 1, 1 to the first power is 1. 1 squared is 1. 1 cubed is 1 times 1 times 1. That's 1. 1 to the fourth is 1 times 1 times 1 times 1. 1. Okay, 1 to any power is 1. Okay, so that's the first law of exponents. Okay, next. All right, if you have something like think of A as being a base, okay? So A is raised to a negative power, okay? We've seen in this section already how to eliminate a negative exponent. Negative exponents don't really make sense to us, okay? So remember what you do to eliminate the negative exponent, okay? You do 1 over the quantity, okay, so I'm going to do 1 over A to the negative S power, but then you have to change the sign of the exponent, okay? So this whole thing becomes 1 over A to the S power. That's how you can eliminate the negative exponent, okay? Next, if you have something to the 0 power, what's that going to be? Well, we talked about this too, okay? It's 1. Anything raised to the 0 power is 1. Okay, that's a very handy thing to know. Okay, all right, going on to the next row. Okay, the first 3 laws of exponents, the ones we just went over, we have seen in this section already. The next 3 laws we haven't seen yet. Okay, you should have learned this in a prior math class. You may have forgotten them, so this is a good refresher. Okay, so A to the S power times A to the T power. Okay, let me give you an example here. Okay, so notice you've got 2 powers here that you're multiplying together. The base is the same in each case. So you might have something like 2 to the 3rd power times 2 to the 4th power. Okay, you've got 1 power of 2 that you're multiplying by another power of 2. Okay, the bases are the same here. They're both 2. Okay, so what this is saying, if you have a power times another power and the bases are the same, you can combine them into 1 power with the same base, and you do so by adding the exponents. Okay, so this would combine and be 2 to the 7th power. Okay, so if you do it generically here, if you have A to the S power times A to the T power, what we're going to do is we're going to keep the same base and we're going to add the exponents. So this would be A raised to the S plus T power. Okay, if you forget, the rules, because the next law is very similar, what you can do is just write out what's going on to help yourself. Okay, so like if I was trying to do if I was trying to do 2 to the 3rd power times 2 to the 4th power and I couldn't remember what to do with the exponents, just write it out. If you have 2 to the 3rd power, that's 2 times 2 times 2. And then if you're multiplying that by 2 to the 4th, that's 2 times 2 times 2 times 2. So you end up multiplying 2 by itself 7 times. So it becomes 2 to the 7th. So you add the exponents. Okay. All right, like I said, the next rule is very similar. So make sure you know the difference between these 2 rules. Okay, they are going to be very helpful with exponential equations. Okay, the difference with this law right here, when you have a to the s, that quantity, and then you're raising it to the t power. Okay, here this is a power raised to a power. The law that we just looked at is a power of a times a power of a. Okay, so it's a little bit different. Over here, the law that we just went over, you have two powers that have the same base, and you're trying to combine them into one power of that base. Okay, but now you've got a power raised to a power. Okay, so in this situation, you might have 2 to the third. Okay, that's your power, and then you're raising that to the fourth power. Okay, so this would be an example of this new law. Okay, so what you would do here in this case, okay, if you have 2 to the third raised to the fourth power, what you would do, that means you're to take 2 to the third power and multiply it by itself 4 times. Okay, so then you could break down each one of these. Okay, the first 2 cubed is 2 times 2 times 2. And then the second 2 cubed is 2 times 2 times 2. And then the third 2 cubed is 2 times 2 times 2. And then I'm out of colors here. The fourth 2 cubed is 2 times 2 times 2. Okay, so you end up multiplying 2 by itself. If you count up all the 2's, you have 12 of those. Okay, so this would be a situation where you're going to multiply the exponents. So if you have a power raised to a power, this is when you're going to multiply the exponents. So you would keep the same base. So a to the s, that quantity raised to the t power, is going to be a raised to the s times t power. Okay, make sure you understand the difference between this law and this law. All right, lastly, if you have the quantity a times b, and then you raise that quantity to the s power, I don't know how much you'll use this one, but I guess it's still good to know. What you can do here is you can take everything inside and raise it to that power. So this would be the same thing as a to the s power times b to the s power. Okay, so an example of this one, I'm not going to go into great detail with this one. Like I said, I think this law right here and this one, these are the two biggies. Okay, so I guess an example of this one, let me make something up. If we had 2 times 3 in parentheses, and then we raised that to the fourth power, okay, you know, probably your best bet would be doing what's in parentheses first to get 6, and then raising that to the fourth power and doing 6 times 6 times 6 times 6 to get an answer. But it is equivalent to doing 2 to the fourth times 3 to the fourth and working it that way. Okay, like I said, I wouldn't worry too much about this last law. I would really concentrate on a power of a times a power of a, where you add the exponents, and then a power of a raised to a new power where you multiply the exponents. Okay, again, these will be very, very handy when we start solving exponential equations here in just a minute.